Hi guys, I'm bringing you a game on Domination Skidrow today, and I will be talking about OCR chemistry F324. Okay, so if you're doing another exam board, I suggest you watch this anyway because there's a lot of overlap. Okay, so arenes, you have to compare the calculated structure with the delocalized model of benzene and compare and contrast in terms of hydrogenation bond enthalpy and CC double bond length and relative resistance to bromination. Electrophilic substitution of arenes, you need to know HNO3 and concentrated sulfuric acid catalyst. And you need to know how the equation of how the NO2 plus ion is formed and how the H2O is regenerated because it's a catalyst. For the halogenation of benzene, it's the same but with the halogen carrier. You need to know the mechanisms for both, and you have to explain the relative resistance to bromination in benzene because it has a delocalized electron density, therefore it has a low electron density, and so it's less likely to polarize a dipole. In contrast to an alkene, where it has localized electron density in the CC double bond, so it's more likely to polarize a dipole because of its increased electron density. And in phenol, there's a lone pair in the p orbital of the oxygen, and that's delocalized into the pi system, or the pi ring, and that increases the electron density, and so increases the probability of phenol polarizing dipole. So you do not need a halogen carrier for phenol for it to be halogenated. In addition, you need to know reactions of phenol with alkalis such as sodium hydroxide and metals such as sodium, as well as the bromination of phenol to form 2,4,6-tribromophenol, which is a white precipitate. The uses of phenols include plastics, antiseptics, disinfectants, and resins and paints. Resins and paints because it's used to synthesize azodyes. Once you have nitrobenzene, you can synthesize it into a phenylamine, and by this you heat it under reflux with concentrated hydrochloric acid and a tin catalyst, and you form a phenylamine via a reduction reaction. The phenylamine may be reacted with concentrated nitrous acid, concentrated HCl, and under 10 degrees Celsius. The nitrous acid is generated in situ via sodium nitrous, which is NaNO2, to form NaCl plus HNO2, and that all of those reactants go under a diazotization reaction, which forms a diazonium salt and 2 molecules of H2O. And the diazonium salt may be reacted with a phenol in alkaline conditions, so you add NaOH, so it's reacted with phenol to form a azodye via a coupling reaction, and that is all done under alkaline conditions, blah 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 blah. Uses of azodyes, resins and paints, dye stuffs, literally uses of phenol. Reduction of carbonyl compounds. You need to know the oxidation of primary alcohols to carboxylic acids, secondary alcohols to ketones, primary alcohols to aldehydes. You heat it under reflux with acidified potassium dichromate to get a carboxylic acid and ketone, but you heat it and distill to get an aldehyde. Color change is orange to green. Reduction of carbonyl compounds may reduce aldehydes, ketones, and carboxylic acids to either primary alcohols or secondary alcohols. Reduction of compounds using NaBH4 is the same. You heat it under reflux. And you need to know the reaction mechanism for NaBH4 and the reduction of carbonyl compounds, where you use a hydride ion. In reality, the hydride ion doesn't actually exist. What happens is a barium complex forms, and that acts as the nucleophile. But you don't need to know that for A level. Okay, so you can detect such aldehydes, carbonyls, ketones using 2,4-dinitrophenylhydrazine, also known as 2,4-DNP. You add 2,4-DNP to your solution and a yellow precipitate will form. You measure the melting point of the yellow precipitate you measure the melting point of the yellow precipitate, and then you can compare that melting point with a database of known melting points of carbonyl compounds mixed with 2,4-DNP. And from that, you can identify your carbonyl compound. You can also use tolerance reagent to detect the presence of alcohols. Aldehydes. You use tolerance to detect aldehydes. By this, how it works is tolerance is ammoniacal silver nitrate, and the silver ions are reduced to AgS, whereas the aldehyde is oxidized to carboxylic acid. And so you get a silver precipitate forming or a silver mirror. Either works. Carboxylic acids and esters. Carboxylic acids are soluble because they form hydrogen bonds and permanent dipole-to-dipole interactions. Carboxylic acids react with metals, carbonates, and bases, and you have to describe them. Esterification of carboxylic acids with alcohols in the presence of acid catalysts. Concentrated hydrochloric acid, heating under reflux. You can hydrolysis of esters, alkali hydrolysis, acid hydrolysis, heat them both under reflux. For alkali hydrolysis, you get a carboxylate salt. You can also synthesize esters from anhydrides with an alcohol to form a carboxylic acid and an ester. Esters are used in perfumes and flavorings. Triglyceride is a molecule of glycerol, propan 1,2,3-triol, and 3 carbox and 3 fatty acid chains. A fatty acid chain can either be saturated or unsaturated. Saturated have no CC double bonds, whereas unsaturated do have CC double bonds, and you can have cis or trans isomers of unsaturated fatty acids. The trans isomer is bad for your health. It increases LDL and decreases HDL, so it's linked to coronary heart disease, atherosclerosis, and strokes. And esters are also used in biodiesels. The esters of fatty acids are hydrolyzed and then added to biodiesel. This would increase the efficiency because fatty acids contain the oxygen in them, so there's more oxygen, therefore less incomplete combustion, and also it's renewable, in contrast to fossil fuels. Amines are basic, they have a lone pair which accepts electrons. Preparation from aliphatic amines from halogen alkanes, excess ethanolic acid solvent, and excess ammonia, heat under reflux, goes under nucleophilic substitution, synthesis of azodides, chromatography, and chirality, and NMR are all needed. That's module 1 complete.